2, they say that we have to calculate the volume of C expressed in terms of R, right? So now we have calculated the cross-section, the area of the cross-section C, which is resulted in this. Now we have to calculate the volume for this cross-section in terms of R. And the way to calculate that is to actually imagine that this cross-section is turning around from here, this point to there. It will eventually create some room. And you know that if we are in the in the function, we can calculate the volume using the integral. Okay, so the value is integral from minus R to R. Okay, and then we put this in, and you see that I have make this one is not t, it is x, because in number 2 you see that it says it express it in terms of R, and it didn't say that I have to change the x to t or whatever. Okay, and you also see in number 1 why I make this limit from minus R to R, because in number 1 said so, from minus R to R. That is the place for the cross section of C. Okay, so here it is, guys. The interval is from minus R to R, right? So from minus R to R, that is the place of the cross section. Okay, and number 1 is to calculate the cross section of C only when x equals t. And in number 2, we calculate the volume of the cross section C from interval of minus R to R. Okay, so that's why I make the limit minus R to R there. Now we only calculate this integral, and remember that we can actually, I want to do that without the limit first. So I want to calculate this way. Okay, so this is equal to half r squared minus half x squared dx, and remember that we calculated in the variable x. Okay, so we consider this as a constant. Okay, so the constant, we can actually separate that to half r squared dx, right, minus half x squared dx. And remember, constant, when it is directly integrated, it comes out with the variable x, right? What I mean is, when you integral 2, this is actually become 2x, same as this. So we turn that into half r squared x. Okay, and we calculate this integral, which is minus half times the third x to the cube, right? You remember, guys, that integral of x squared dx is a third x cubed. Okay, so this is equal to half r squared x minus 1 over 6 x cubed, and remember, we have the limit from r to minus r. Okay, so this is equal to, and remember, do you know how to calculate the definite integral? You substitute the x. Okay, so I substituted the x first. Remember, first is the upper limit. Okay, and the second, you subtract it and you substitute it with minus r. And you see, that's the way how you calculate definite integral. And this is the task for you guys. Try to understand on how to subtract this, and the answer is 2r cubed over 3. And you should have known how to calculate that.